Hi, welcome to Project Geospatial. I'm Adam Simmons, and we're here at the Edgybees booth with Craig Brower.
Correct.
Yeah,
Craig
my
Brower.
lips. Yes,
yeah,
right.
not a problem.
All right. Go ahead and introduce yourself.
Sure. So
And,
my name is Craig Brower. I'm the president of Edgybees Inc., which is our U.S. company, which is the company focused on U.S. government and areas that are unique to the U.S. government and how we can support them in all of their environments and surroundings. So.
Perfect. How did you get involved with the geospatial industry?
So mine started actually way back. I actually, right out of college, I went to work for a contractor for a few months, and then I ended up going over to CIA and worked for the predecessor to NGA. Back then it was called NPIC, then became NEMA, and then after that I got into the industry side and worked with companies like BAE Systems, Digital Globe, was another startup earlier, a couple years ago called Vricon, and then ended up in October joining these guys. So
Awesome. Did you know the industry was going to grow as big as it was at the time?
Not as big as it is, yeah. That's a little bit of a surprise, but it's been going well, and what we're doing and the quality of what we're getting now from space is just incredible. So
Awesome. Well, let's dive right into the
Sure.
company you represent.
Sure.
Who are you,
Yeah.
and what do you actually do?
Yeah, so Edgybees, we're plain and simple, we make things accurate. We make everything accurate. So we are in the business of geo-registration. So what we do is we take, a lot of folks don't understand that video coming from drones or aircrafts or even satellite imagery is not inherently accurate. So it could be off by 20 meters, could be off by 150 meters. And so what we do, we're a software only solution that makes that data accurate. In the case of video, we make it accurate in real time. So as it's coming in within 120 milliseconds, we're correcting that video to the ground so that users and operators know exactly where they're at. If they want to drop a point on a building or they need precise measurements and information, they can do so in real time.
Oh, that's incredible. What's that margin of error look like? I know, for example, when a predator has a massive look angle, that could be off by 1.5 or even 3 kilometers from an accuracy perspective.
Yeah, so for us, we get things on the video side, we're typically down below a meter. Again, depends on the resolution of the imagery that we're working with. On the satellite product, which is a new product we just announced this week, that one we get down to within 1 to 2 meters. So it depends on the resolution. The higher the resolution of the data we're using to register against, as well as the data coming in, the better the accuracy gets. So we'd roughly get within 2 pixels, is one way to say it, of the worst imagery that we're working with.
Excellent. So what other services that can users take advantage of while they're taking and looking at your...
And what you're seeing here, this is again showing you how it's corrected if the Wi-Fi is a little bit slow here, so it drops out. But if I uncorrect it, I'm turning it off, you'll see this is what this is how far off it is. It bounces around, it's jittery. So for the operator of a drone, we now give you that differently, a stable look. It's accurate, you can do your analysis. The other thing is if you were like following a vehicle, here you would be able to see where the vehicle is going to go next based on the roads or tunnels or things like that. We also provide a different look at this, and we provide, I'll pull over to this one, we also provide the ability to overlay additional data. So another view of this is you're watching the video come in real time, and then we overlay, this is zoomed in a little bit right now, but when it zooms out, you'll see all the roads, the building annotations, things like that. So we give that operator that full contextual view of what they're doing and where they're at on the ground. And here you can see you can drop in points. You can drop points in real time, give those coordinates to other folks. And again, this is all in the video world. So this is the very quick turnaround video solution.
What's the output of this? So after either the mission's going on, they're like, oh, I want to get a snippet of this, right?
Right.
And I'm going to send a snippet of this product to one of my customers. What's that process?
Yeah, so you can literally just record that snippet and send it to them. You can also export out all of those points and vectors that you've dropped in during the mission. Those can all be exported out as standard files, vector files, and then you can send those to folks for the after actions. So both are there. The other thing too is now that video is now corrected forever. So once you do it the first time, now you store the corrected video. So if anybody's doing second, third phase analysis, it's all corrected for them.
Awesome.
And then the second thing I will show you, we do have another product that we just released this week. And here we're taking advantage. I won't actually upload the image just because it takes a little bit of time to upload. But here we can take commercial satellite imagery, EO right now for the first release, and we can literally drag and drop it to our cloud server. We will go through and correct it, and so we'll have the original accuracy, our corrected accuracy, and then give that image back to you corrected. That happens in a matter of seconds. So again, video is milliseconds, satellite imagery is in seconds. So this one, I grabbed an image here. This is over, I think, Snake River. And this particular image that we got the raw form of the image. came in and it was off by 76 meters. We corrected it to within 2 meters, and we did so within 8 seconds. So the original image here, if I pull this up, you'll see, I'll zoom in a little bit so you can, let's find an area here where the registration is really noticeable. So here you'll see, well, that one's not as noticeable. Where's the other corner?
What do you correct it to? Is it a specific DEM or?
So we correct it to the customer's, whatever the customer considers to be their foundation.
Okay.
So in this particular example, I'm using Esri's web mapping tile service. It could be any web mapping tile service. It could also be any customer's ortho data as well as elevation. So whatever that customer considers to be their ground truth, that's what we register to, so that then everything that analyst does is now matches everything that is in their desktop and they're used to. So it is a relative accuracy, so it's relative to what we map to. But again, we can map to as precise a data as you'd like.
And for those in their audience who don't understand the value of this, because it is extremely valuable, I spent as an analyst so much time just trying to align my imagery. If I didn't align it, I'd spend just so much time trying to find my target, trying to mix and match between multiple images to make sure I got the accuracy right.
Exactly.
It sounds simple, but it's a massive time waster having to do it manually. And analysts still do. They still do it manually.
Yeah, and if you look at this example, so this is the original image, and you see the 76, see this building here? It shows up there. So that's the kind of difference we're talking about.
And
see the rings here?
And that matters when you're doing reporting, especially on target-specific reporting, where you're maybe even sending this downrange where they have to drop onto the target.
Exactly. And now in this version, now this is the corrected version, you see everything lines up. So we went from 76 meters off to 2 meters off in 8 seconds.
Incredible.
And again, even the 8 seconds is just a matter of compute time, and all this is cloud-based. So this software and the product that we just released kind of comes in 3 flavors. One is it's a web interface. I can drag and drop an image, get it back. The other one is a batch process. So I could tell you, say you had a project, you're working 100 images. You could just upload the 100 images, have it processed, go to lunch, come back, it's all ready, and do your work. And then the third one will be the streaming version. So you'll actually be able to stream the data right to your desktop as it's coming in. So the idea behind this software, again, software only solution, but that it sits as close to the data as possible, and we correct the data early upstream so that then everything you do downstream, ortho rectifying, pan sharpening, all those processes take place after we do the correction.
So from a workflow standpoint as well, and you kind of hinted this in another area, users can upload their imagery, and I'm assuming they also can connect to an imagery archive or directory of some sort as well.
Exactly.
And from the video side of things, from the streaming, is that a matter of just plugging in the right IP address for their
correct
for their video?
Yeah, it's a matter in both, and I'll explain one other piece to this as well. Both things to keep in mind in both cases, video and in still imagery. We do not disturb or modify or warp the imagery source in any way.
And that is important, because I had to do that myself just to try and get something.
Exactly. So what we do in the video case, the video comes in, there's underneath it is what's a file called a KLV, which is the metadata where it's at. We correct that KLV file, and we give you the original video back with the corrected KLV. In the case of satellite imagery, the image comes in with RPCs. We correct the RPCs, give you those back.
Excellent.
So we don't disturb the image in any way, because again, folks are, especially this audience, gets very sensitive. People start messing with their images. So we're not messing with their image, we're just correcting it.
Well, if someone wanted to use not necessarily the front end interface for looking at the video, and could they use this as kind of a processing engine as well?
Yes,
just
exactly.
Send the imagery through the pipeline, automatic more accurate stuff.
And then we're working with all the major, on the video side, all the major video exploitation packages and those companies. There's like BAE Systems, we've got cards here working with them. We're working with companies like Novetta, all the Lidos, all these companies that have those exploitation packages. We're just an API inside their system. We don't want to do a new front-end desktop. We have one, we show people and people can buy it, but we're not that front-end company. We're that process that goes into your existing process, and we just correct it along the way.
Yeah, this seems like a natural place to put on the in the pipeline as the daily take comes in.
Exactly.
And before it even reaches the analyst, it's already run through, corrected, and it's ready to go.
Exactly.
Awesome.
So,
well,
that's us in a nutshell. And again, back to we make the world accurate, and that's our one mission, which is good. As a startup, we have to be singularly focused, and so we're working that on the video side. The EO right now, we are released on the EO side. By the end of the year, we also plan to do this for SAR as well, commercial SAR. So we'll have video, EO, and SAR all registered to the same standard. So
For those interested and they've watched this, how do they get a hold of you? What's their recommendation?
Sure. So our website, edgybees.com, is the easiest way, and there's an inquiry button there. And again, we're here obviously at the GEOINT conference, and we're at most of the major conferences, so you'll see us around here in the coming months. So.
Well, thank you for giving us a rundown of Edgybees. And this has been an awesome demo here. I'm Adam Simmons of Project Geospatial. We'll talk to everybody next time.